Okay, so what you're going to be looking at in section 5.3 is finding data values when you are given an area under the curve. So I mentioned to you in class that this section was really going to kind of take what we've been doing and really flip it around and look at it from the other direction. So what I mean by that is we have been up to this point, we've been looking at problems where we were given a data value. Maybe it was a z-score, maybe it was a height or a speed or a weight, but we were given that data value and we were asked to find the probability, which is the area under the curve. In 5.3, again, we're going to kind of flip this thing around, and instead of being given a data value, we're going to look at situations where we are given an area under the curve. And for that given area, we're going to look at how would we find the data value that corresponds to that. How would we find the speed or the height or the z-score that corresponds? So just like we did when we were learning how to find the area under the curve, we're going to start and just talk about doing this for values of z. So given an area under the curve, we want to talk about what we would do to find the corresponding value of z. All right, so I want us to go ahead and look at our first example. We're going to be following the steps that are defined here, but I want us to go ahead and look at our first example to get a better idea of what these things are going to look like and how you should approach each problem. So the first example here, the first thing I want to note is that it's asking me to find a z-score. Not find the probability, not find the area, but find a value of z. So that means when I state my answer, I should be stating a value of z. The other thing is I want to be very clear about what information I'm given. And in this case, what I'm given is an area under the standard normal curve. Now, I also mentioned to you in the last couple of classes, I said make sure that you are labeling values, like if it's a z-score, label it as z. If it's an area, label it as an area. That's going to become even more important in this section in just making sure that you're not confused about what you have and what you're trying to find. Now, once I do that, once I've laid out what I'm looking for and what I'm trying to find, the next thing I do is I kind of look at the area that's given a little bit. Number one, I want to make sure that what I'm given is an area to the left. All right, cumulative area is what's given here, and we know that's an area to the left. The next thing I usually do is I look at the area that's given, and I talk about whether it's less than half or more than half. That's helpful because it tells me whether I'm going to have a positive z-score or a negative z-score. So in general, if the area to the left is less than half, that means you're on the lower end of the curve, which means you're looking for a negative z-score, and that's what we have here. If the area to the left is more than half, then you're on the upper side of the curve, you're past the halfway point, and that means you're looking for a positive z. And then the third thing that I do is just kind of give myself an idea about what this shaded region would look like in terms of how big or how small it's going to be. So the other thing I want to notice here is not only is this area less than half, it's very small. 0.0217, we're talking about only about 2% of the area under the curve to its left. So not only is this going to be a negative z-score, but we're going to be pretty far down the left side of the curve. So what this would look like in terms of my graph would be a z-score pretty far down here on the negative end of the curve. Now z I don't know, that's why I just labeled it z because I'm trying to find it. And what I'm given is that the area to the left, this little small region right here, is what I was given at 0.0217. All right, so if I look at a question like this, or if I'm given a graph like this, where I see that what I'm given is the area under the curve, then when I take that to my standard normal table, I want to be very clear about the fact that areas are found inside the table And specifically, these are always going to be an area to the left. So my area to the left here is 0.0217. Because it is an area, I'm going to search inside my table for an area of 0.0217. Now, you will have to do some searching because you got a lot of values in here, but they go in order. So you'll notice they start really small up here, and then they increase. So we continue to increase. We come to some values around 0.01. Then eventually we come to some values at 0.02. And if I just keep following the trend, then I'm going to see that exact area of 0.0217. And then keeping in mind what I'm trying to find here, what the question asked, right? What is the z-score that corresponds? So using the corresponding row and column, I can read off my z-score at -2.0 with 2 in the hundreds place. All right, so again, just using the row and column, the row gives me -2.0. The column tells me there's a 2 in the hundreds place. And this is the z-score that has a cumulative area of 0.0217. All right, so in general, you want to understand what the sketch would look like. Is the area large? Is the area small? Keeping in mind that when the area is less than half, you have a negative z-score. When the area is more than half, you have a positive z-score. And then other things to make sure you remember, we want to make sure we're doing this in terms of area left. We want to make sure we remember that areas are found inside the table. And then we want to read off the z-score using the corresponding row and column. All right, now I know a lot of you have been using Statcrunch in place of using the table, and you can use that here as well. With the normal calculator, you just have to be very careful that you're putting values in the right box as far as what you are given. So what I mean by that is if I wanted to use the normal calculator here, just like we always do, I would go calculators and normal distribution. And then what I want to remember is that first of all, if I'm looking for z, the mean and the standard deviation will not change. 0 and 1 for the standard normal. But when I look at the 3 boxes on the next row, the less than greater than, that's just a matter of am I looking left or right. The box that comes after the less than greater than, that is a box for z-scores or data values, heights, speeds, weights. The box on the right-hand side of the equal sign, that's what's giving you probability, which is the area under the curve. So if I'm taking an area to my normal calculator, I want to make sure that I don't put it in the z-score box. I want to make sure that I put it over here in this box on the right-hand side to show that it is an area under the curve. And when I do that, if I hit compute, then it will fill in that z-score box or that data value box, and that'll tell me the same thing that I just saw from my table. If I round that to 2 decimal places, the z-score that corresponds is -2.02. So what I would encourage you to do first is go through the homework, go through the practice, and work through a few examples where you are specifically given an area to the left. All right, just get this kind of method down of, where do you look for the area, where do you put it in the calculator, and can you get the corresponding z-score? And then once you do that, I want you to come back and watch my second video where we look at how to handle it if the area that we're given is not an area to the left.